In this lesson, I really want to show you how you will build a foot setup. Okay, so here we have pretty much the same leg setup I showed you before. So let me just hide this mesh for a moment, and you can clearly see it's a standard IK setup we did. We have a pole vector here on the side, so we actually don't have any flipping occurring. Okay, so we can go all the way around. And I showed you all this in previous lessons. Here I will show you how to build a foot setup. And the foot setup really depends on what kind of functionality you want, because there are many ways to rig a foot. So let's just doodle the functionality we want. So let's say I want this foot to really follow all the movement of this joint chain. I already have this IK chain, and I want to have some additional controls. I want to be able to freely rotate the foot, and let's say I want some sort of heel lifting effect. So this all should really go like this. Unhide this mesh. So basically it's like lifting off from the fingers feature. That is what I want. And of course I want to have the ability I can remove those fingers wherever I want. And of course I want it to be really non-destructible, so it works with the existing leg setup that we have. I'll just collapse this existing setup so it doesn't bother us. Okay, here we can delete this little guy. I will collapse this also, and these two things, these two guys, are basically the leg setup. You can see it's a classic IK goal and some sort of joint chain with master control. We have already built that, so we want to concentrate on this next joint chain. And here I have 3 joints. Just press the S key to zoom on that guy. You can see I already arranged them before, so I have a ankle joint, ball joint, and the toes joint. They're aligned. The z-axis is pointing down the chain, and we are pretty much good to go. One thing that I also want to say, you see this foot controller object, this is actually a spline, and I just traced really roughly a spline object that should represent the shape of the leg. And splines are really useful as controllers because they don't render, and they can get any shape you need. And I want to use this foot controller, this spline object, as our main controller for my foot. So if I move this guy, then all the chains will move, including this existing IK and this new one we will build. Also here you can notice that this foot controller has the axis positioned exactly where this heel goal is. So they're in the same position, and they have completely the same rotations. And there is a good reason for it, simply because this foot controller guy will be the parent of it. So we want everything to occur from here. Currently our joint hierarchy is set up in this manner. So this means if we manipulate any of these parent guys, the child will follow. So we have instantly a big problem, because we want this guy to follow as we rotate this. And to do that, we will help ourselves with the help of null objects. And the reason why we are not creating a different hierarchy here is because we are going to apply weighting to it, and you have to keep as much sense as you can. So let's convert this object as it is to a null. Let's go character conversion, go convert to nulls. Now we have a null object which can be used as a parent object. We can pull it out here, and we can actually drop complete hierarchy of these guys inside. And now if we will actually rotate that object, it will all rotate together, but the origin of the rotation will be here, just as we want it to, from this same position. Let me undo all that. The other thing we would like, I will just hide this mesh so we can see it more clearly. So natural movement would be for this guy, for this complete chain to follow this joint. Okay? So because if you lift your foot, you will see naturally that your heel and a complete leg is following. So to do that, we will simply drop this heel goal, and you can see why I'm keen to put all my goals object outside of their, let's say, natural hierarchy, because they have some sort of a flexibility. So if I drop this here and now rotate this ball, I'll simply rename it ball lift, so it has some sense. Now if I will rotate this guy, watch what happens. I have complete chain following. It's really nice. That is exactly what I want. So now we have that part done, but it seems illogical. And it seems illogical because this guy should stay on the floor. It should not move at all if we rotate this. So how will we do that? Since there is no lock constraint in Sina for the at least really that simple one, we could really use again some sort of a smart parenting. I will create another null from this same joint. Let's go character conversion, convert to nulls. And in this case, let me drag it out somewhere, let's say here. And I will rename it toe controller. And we'll once again use some sort of a smart parenting. And in this case, if we want to break the connection between these two guys, between ball and toes, we have to create another parent for this toe guy. And to do that, we will do that with a constraint tag. So activate the parent option. Don't forget to check this maintain original, because if you don't check it, then it will really instantly, this toe guy will pop to a position of this new toe controller. Okay, so maintain original, and we will use this toe controller as a parent. We will activate both position and rotation, so this toe controller is now the parent of this toe guy. So let's give it a shot. So now actually we can simply control that behavior. The difference now is, since this toe controller is outside of this hierarchy, it won't be manipulated if we do this. And since we want all these guys to be controlled with this main foot controller, we will drop them all as children of foot controller. So let's really check once again. So we have an option to move it all, and do that. We have the option to rotate all. We also have the option to lift the heel. And we have an option to control these toes. So this is one way to build a foot setup. So this is really good, but I prefer another option here. And another option is to create user data sliders for my toe controller and ball lift. So I want to have a slider with which I can lift this guy, and another slider with which I can control the toes. So I have it all at the same time on the same controller. Naturally, you can have a different idea, but I really prefer to work with one controller that controls pretty much everything and has additional options. And I kind of avoid having too much controls that I have to select in the viewport. That really is not the way I like it. So let's add that user data. Add user data, and we'll call this one heel lift. That type will be float, interface will be float slider, and everything else to default. I'll just copy this once again and simply rename it to toes and leave everything else as it is. Okay, let's first check how much that ball lift has a degrees of movement, so to say, and just to be sure, please select everything because you can see some wild values here. You don't want to really experiment and find out how much you have to rotate something or put these kinds of values in Espresso. So let's just select all and simply here under coordinates we will freeze the transformations of everything. Okay, so we are now good to go. Now let's see here in the object relative mode how much is actually that heel lift happening. So let's read it out. Let's say it's maximum of minus 70 degrees and of course none in the opposite direction. So let's add the espresso tag here and simply create that setup once again. As usual, you can pretty much know what I'm going to do with this window. I will dock it and I'll drag the foot controller here. I will extract the heel lift and the toes. Firstly, I will set up this heel lift, and that is really simple. All we need is this ball lift null object here, and here you can read which rotation is that. You can see it's rotation P. So let's undo that and drop a range mapper here and tell it what to do. So connect it. We will tell that our input range is in percent, since our heel lift controller here is in percent, and we want to output degrees. So we want to output degrees for this ball lift guy. How much? If you remember, we want it to control minus 70 degrees. So from 0 to minus 70 degrees. That would be pretty much the maximum value. All you gotta do now is simply find the rotation P here and connect those two guys. And here we go. We have a nice heel lift setup. Since we are at it, let's do toes also. So you can see, actually want to be able to rotate these guys in both directions. So we will have to make minimal changes. So let's see how much would that be. It wouldn't go over 75 in my opinion in both ways. So the thing I want to change is actually it would be much better for this toe slider to go from minus 100 to 100. So we have a middle value, the default value of 0. So let's manage our user data and simply define that. So the minimum value here will be minus 100, and that's all there is to it. Now, once again, the almighty range mapper node, we will copy it. All the settings here are completely the same, and we want to drop this toe controller here, also rotation P, and we want to connect it, but we will tell here under parameter it will state somewhat of a different value. So input lower is from minus 100 to 100, and each of those guys really corresponds to 75%, let's say. So 75, and -75. So let's see what do we get now. Let's give it a try. And there you go. We have a nice toe wiggling. I think we can actually get rid of this espresso window to get some space here. And we can move it. We can rotate it. Will it reset properly? Yes, it will. We can play with toe wiggles. You can even lift it. And it really works. It is really nice. And let's now bind that to our mesh and we will solve a few problems. And I will show you a really nice usage of smoothing deformer. So let's select our foot controller and simply reset the rotation, reset the position, and we can also reset this guy to 0. You can see we had some sort of a refresh problem, but that is easily solvable. You can activate this automatic redraw every 50 milliseconds is just fine, and you won't have it. So let's reset position and reset rotation, and you see all joints are following as they should. Before we bind this, let me just try something out, and yes, this will be a problem. Let me undo that. So this should not happen. This foot controller should not be able to move away from this leg joint chain. That is really bad, and we cannot use as earlier here. You can see under advanced tab of the IK, we cannot use this constrain goal option simply because the goal is not actually this foot controller. The goal is this heel goal. So we'll have to resort to some sort of tricks, and we will use a clamp constraint, and let's say that really what we need is that our foot control should never exceed the distance from, let's say, this master controller. Even we will get additional functionality. So this would be maximum distance that this foot controller can be from our master controller. So if we set it up like this, there is no way we will be able to move it away from the chain. So let's give it a shot. Let's drop the master controller here and leave this to origin. And the origin in this case will be the axis of this master controller. And we don't want to fix anything. We want to say maximum. Okay, so because this, as seen now for the assumed and calculated this distance, will be the maximum distance we can move foot controller from our target. I also suspect we will have another problem, so let's find out. And you see we have some sort of really strange wobbling. Let me just do it and zoom out a bit. Watch this area here. So look how it behaves differently. It's really some sort of jiggling going on, and that is because of the priorities. First I will drop this constraint tag after the espresso, and doesn't hurt to put this whole hierarchy of the foot controller on the top. So let's give it a shot now. Now it works as it should. There is no more wobbling of those joints. Let me undo that. Only one thing I will do, I will uncheck this draw clamp, since it draws that red line exactly on where the IK is drawn, and that could be a little bit confusing. One additional nice thing we got while we clamp constrain this to master controller is actually this guy will move if we move that master controller, since it will tend to keep that maximum distance. Okay, so let me undo this. Foot controller, also reset position, reset rotation, and just before binding I will select absolutely everything, because I just want to be double sure. And never mind that you see 0 values here for rotations and for positions. Simply click once again freeze all just to be sure. And we are ready to bind it. So let's find all the joints here. So this hierarchy and this also, and of course our leg mesh, and go once again character command bind. We'll of course unhide the mesh. So let's see what do we get, what kind of deformations that auto weighting provides for us. So far it looks good, but let's see. You can see there are really some bad deformations going on here. So let me undo it. And let's try our heel lift. And it's not working as it should. And I will tell you why. And this toe guy will especially do nothing. And this is because there is actually no weights applied to this last joint. That is exactly what we need in most of the time. So for example, for this heel, there is no weighting applied. The same goes for this joint. There is no weighting applied at all. Let me just open my weights manager and let's see if we select that toes guy and we'll disable this hyper nerves. Will we see any weighting? We will not. What about this ball joint? And you can see that this ball joint really controls it all, and we don't want that. We roughly want, let's say, this area of the mesh to be weighted to this toe joint. So we can really do just that. We go to faces mode and I already selected this. And if you're wondering how did I select all this, it's really simple. I just select the loop and do a fill selection command on the rest. So I will select my toes joint, and here I will set this to 100% in absolute, so I will hit apply and all that will be 100% applied to this currently selected joint. Okay, so let's close this and see what we have. We will try our heel lift and it works much better. Let me undo it and we can, let's say, wiggle our toes. I could really do a finger each toe separately, but it would take really significant amount of time. So let's give it a shot how it works once in a deformed position, and you can clearly see if I enable hyper nerves, we are losing volume in some areas, and under skin deformer I will once again enable spherical, and the situation will become better in many areas, but we will still have a problem here. And I'm deliberately now showing you this because I will use a deformer to fix this area. So there will most certainly be many situations where you simply don't have a time to do proper weighting, especially on complicated meshes, on the meshes that you got from the client and so on. There are a million reasons why that wouldn't work. See, this is a pretty good job with the auto weighting here. So let me reset all that and show you the usage of smoothing deformer, which is a really nice and welcome addition in release 12. It's really used to help you keep the overall volume and to smooth out certain imperfections of the mesh. So let's find some pose where we have a problem and we actually don't have to search a lot, and although you can fix many of these issues here with weighting, you can see we are losing volume here and the knee is bulging out too much, and you can correct this kind of thing with smoothing deformer. So select the leg And here under Deformers menu, hold down the Shift key and click on this Smoothing Deformer guy. And you'll instantly see that our leg has lost weight, but be sure to put it after the skin deformer, simply because you want all that weighting that is actually done, and all the deformations are kept inside the skin deformer. So you want to put every other deformer after the skin deformer. This will be really simple. This initialize simply means it will initialize the deformer itself, so you won't lose the initial state. The strength is really self-explanatory, and here are modes of that deformer. For example, if we select relax here, you'll see a completely different result. The type I want here is actually stretch. And you can see it actually looks pretty good, and a difference with this smoothing deformer and without it. If I now hit initialize, I will be able to reduce the strength, and this was our original initial state, like we don't have a smoothing deformer. Okay, so simply like we turned it off here, you can see this is our normal deformation. So look how smart it is. It will conserve the volume, it will fix the issues here. For example, look at this area. It will tighten that up. So it's a really, really good addition in release now. Here you can also experiment with stiffness, so you will get a different result, or really make it really tight if you go all the way to 0. If you play around with these values, you will get a feel for it. If you enable these keep displacements, then all the points positioned on the existing mesh will tend to stay fixed, and only the polygons in between them will be stretched. I hope this is not difficult to understand. Then of course you can drag a stiffness map that is actually vertex map. You show that in volume 1, so you can actually define what will be stiff and what will be completely opposite to it. Here we have some pull-off options that are really common for Cine 4D, and I think we are pretty much done with it. So we have a nice foot controller with decent deformations, and we actually did almost no weighting aside to applying weights to this toe joint, because simply we wanted to have a toe control, and of course we have a heel lift that works in also deformed state, and you can see how you can add those deformers to correct the shape, to smooth something out, to add a second layer of deformation. So this is really, really good. Let me reset all that guys to 0. I will save this scene. Save, and let's go to our next lesson.